this video, we are going to cover section 6.3 using the normal distribution. So what we're going to do in this section is we're going to put together the pictures that we did in 6.2 along with the z-score and solving and the mean and the standard deviation, all that fun stuff from chapter 6.1. So we're going to combine it and do word problems. Okay, so here we go. Let me get my right screen up. And okay, here we go with, I'm trying to move my things in the right spot. Okay, number one. Well, first of all, in the instructions, you can see it says, draw a picture for each, round all probability to 4 decimal places. So we know two things. We're going to draw a picture, and we already know what to round each one to. Okay, so here we have the first problem, and it says the random variable x represents a randomly selected 3-year-old's height where the distribution for the score is normal with a mean of 38 inches and a standard deviation of 2.5 inches. Find the probability. So all of these are going to be crooked one. All of these are going to be worded as find the probability. And remember, let me just write a little note off to the side. Remember that the sum of all probabilities equals 1, and the area under the curve for the normal distribution is also 1. So we're going to interchange probability and area. So when it says to find the probability, we are going to find the area under the curve, just like we did in the last video. The main difference between this and the last video is we are drawing everything from scratch ourselves. Okay, find the probability that a randomly chosen 3-year-old's height is between 44 and 41 and 44 inches. So first, what does that look like? So we have our, oops, where's my pen? Okay, give me my pen. We have our curve. So we're going to draw a normal distribution. It says the mean is 38, so that goes in the middle, the 38, and because the mean is always in the middle. And we want to know the probability that the height is between 41 and 44. Okay, so this is a number line. Bigger numbers go on the right, smaller numbers on the left. So we have 41 and 44, and it doesn't have to be perfectly to scale. However, you want to have the numbers in the right order. You want to have the middle being 38, so we can clearly see that we are looking at, let's see, the space right here between 41 and 44. Okay, so we are looking for the probability that x is between 41 and 44. And we can put the lines or not put the lines, just like we've talked about before. It doesn't matter if it's equal to or not equal to, because we're talking about area. But that's what we're trying to find on this problem. So let's look at this in terms of the z-score. And so if we are trying to find the z-score for, we're going to find the z-score for the upper and lower bound. So the lower, I don't know how I'm right in this tiny little space. Okay, the lower, which is the 41, the z-score is going to be, let me just write the formula up here just to remind you, it is x minus mu over sigma. We know mu, we know sigma, and then we have the two different x's. So the lower z-score is going to be x, which is 41. Uh-oh. My computer just went to sleep, but I think this is still up. So okay. Minus mu, which is 38, over sigma, which is 2.5. And the upper z-score is going to be Rx for the upper end is 44, and then the same mu and the same standard deviation. So this is what I'm calling my upper right here, the higher bound, the 44, and this is what I'm calling my lower, the 41, the lower bound. Okay, so I need to calculate both of those z-scores. and I go to my calculator and I have a fraction. I'm going to put it in parentheses, 41 minus 38, and then I'm going to divide the whole thing by 2.5. I get 1.2 is my upper z-score. And then doing that same thing, so I'm going to copy it. Let's copy the wrong thing. Copy my equation, just changing the 41 to 44, and I get 2.4 for my upper. All right, that's the z-score. I want to find out what's going on in between. So we did a between in the last video. So as a reminder, we're going to go to distribution, normal distribution. We have the z-scores, so we want the mean and the standard deviation as 0 and 1, just how it's automatically set. And then I want to go to between, so I go over to the left and I choose the middle picture. And I'm going between 1.2 and 2.4. And so we get our final answer right here, the point, good Lord, that's tiny, 0.1069 rounded to 4 decimal places. So this went, let me write in a different color. This goes into calculator. And the answer, the probability, let me see if I can move this so I can fit everything. All right, let me just make this a little smaller for a second so I can fit everything because I cannot write this one into calculator. P of 41 x 44 equals 0.1069 rounded to our 2 decimal places. Okay, now there perhaps people saw already an easier way to do this, and let's talk about that because we have used, not easier, just like maybe a quicker way to do this. We have used this calculator for z-scores only for the distribution. But if you recall back like 2 steps ago, or 1 step ago, just go back 1 screen, it asked us for mu and sigma. Now we said 0 and 1 because that is required of all z-scores. If you have the z-score, you always put 0 and 1. However, in this problem, what if we skipped the z-score step and we went straight from x into the picture? So if I say that mu is 38, because that is what is given in the problem, and I say the standard deviation is 2.5, then when I'm going in between, because the picture's still in between, I'm going solely off of this picture. I want my picture that I drew to match what's over here. So I'm going to go from 41 to 44. And if you look at the X number line, we have a line here at 41 and a line here at 44, and it's colored in between, just like the picture I drew. And we get the exact same answer, 0.1069. So the 0 and 1 for mean and standard deviation is very important when we're dealing with these. When we're dealing with x's, we can go exactly the mu and the sigma that's given in the problem. So let's try that with number 3. We have average weight of a baby elephant where the distribution is normal, and we have a mean of 234 pounds and a standard deviation of 34 pounds. What is the probability? Let me get ready to check. What is the probability that that baby elephant will weigh more than 250 pounds? So let's go over to our picture. We want to draw a picture every time, and it'll match what's in our calculator so we know we're on the right track. The mean is 234. And our cutoff is over here at 250, which is to the right because it's bigger. And then it says more than, and more than is also to the right. And just as a reminder, well, I'll write it out right here. So we want to write out our probability with the inequality because we want everything ready, put in our calculator. So then all we have to do is match it, and then we know we're on the right track. All right, so we went to my text. All right, we went to probability that X is greater than 250. Now this says more than, which just means greater than. But again, we're finding the area, so it does not matter about greater than or equal to. It doesn't matter because this is like saying, I think I said this in a different video, the blue part represents the grass and the red part represents the fence. We want to find the area of the grass. The area of the grass is the same whether the fence is there or the fence is not there. The grass is still the grass. So we don't care if the fence is included or not included. And that's important because included is the only version that we have. And as we saw in chapter 4, when we were doing the binomial distribution, if it said more than 250, we would have to rewrite the inequality because we didn't want to include 250. But here, because we're finding area as opposed to like that linear value that we were finding in chapter 4, we can include it. So it's fine to write it exactly like this. And we have our mean and we have our standard deviation. So I'm going to go over here. I'm going to go back and type in my mean and my standard deviation. I want to change it to more than or greater than, which is the bottom choice, 250. Now this picture, 234 is the middle. So here's 250 and greater. This picture matches my picture. So I'm on the right track. This probability up here matches the probability that I wrote. So then the final answer is 0.3190, rounding to the nearest, rounding to 4 decimal places. What is that? 10, 100,000, rounding to the 10,000th place, but we'll just say 4 decimal places. Okay, much quicker when we don't have to calculate these. So here we have number 3. The random variable X represents the average number of texts a teenager sends each day. I guess I forgot the word. Distribution is normal. The mean is 450. Oh, yep, I like it with the pretty little underline. Let's go here. I didn't mean to say yuck, but I like it pretty. Mean, standard deviation. What is the probability that they will send more than 700 with a mean of 450? Okay, draw this picture. Got our normal distribution. The mean is 450. We are looking at more than 700. So 700 is going to be on the right side because it's bigger, and we want more than, so we're coloring into the right. I am not drawing these pictures for my help. I'm drawing the pictures for you to practice drawing the pictures because I'm looking for the pictures when I'm grading these assignments. So make sure you have pictures. Okay, so the probability, and it says more than 700, so greater than or equal to 700. I go over here. My mean is 450. The standard deviation is 150. So even though 700 is far away from 450 when you count by ones, not really that far away when you're counting by 150. And I want to change this because right here, the picture looks nothing like what I have. I'm going to change this to greater than. That looks nothing like what I have. So I need to change this to 700. And now I have a picture on my calculator that looks exactly like the picture that I drew. And I can see that the probability is 0.0478. All right. Here, this next one, we have, so if you notice, we're kind of doing the same thing over and over again because we just want to practice this so that, it's new, something different. So we need to practice it a bunch of times to make sure we're on the right track. Number 4 says the time taken to assemble an iPhone at a certain plant. Actually, let me just, no, okay. The time taken to assemble iPhone has a mean of 5 hours and a standard deviation of 3 hours, what is the probability that an iPhone can be assembled between 3 and 8 hours? So I have my picture. Now this one, it does say round to 3 decimals. So we always want to make sure that we're paying attention to the directions because it occasionally changes on the homework. The middle is 5. And we're going between 3, which is to the left of 5, and 8, which is to the right of 5. Now again, is this perfectly to scale? No. But it is in number order, and you do need to have it in number order. Smaller numbers on the left, bigger numbers on the right, in order to have the right picture. Okay, so this is saying the probability that X is between 3 and 8. I'm going to go back. Average is 5. Standard deviation is 3. And we want to go between, so that's the middle picture, 3 and 8. Did I not type it? Oh, 3 and 8. And the picture looks pretty close to what we drew, or what I drew. And I have 0.589. Remember, this one said 3 decimal places, so we have a little different answer. Okay, now something completely different. Not really completely different, but now we're going to go backwards. If you recall from the last video, we talked about going from the probability to the z to the probability, and so forth. So here we have the weight of a baby African elephant. That sounds familiar. Oh, it's just like number 2, just worded just a different type of problem. But it has a baby African elephant with a mean of 234 pounds and a standard deviation. And a standard deviation of 34 pounds. Find the maximum weight of a baby elephant that is in the lower 95% of the distribution. What does that mean? Okay, let's draw a picture. So this is for A. Man, sometimes I really just do not give myself. Okay. The lower is to the left. Okay, I'm going to mute my. You don't need to hear Mario every 5 seconds just because my friend wants to go on hike. Okay, so the lower is to the left, and it's 95%. 100% is everything, so 95% is a little less than everything. So it's going to be somewhere around here. We want the lower 95%. Now, the middle is 234. And we know this colored in part is 95%. All the P words go together. So probability, percent go together in terms of these problems. So 95% is the same as saying 0.9500. The reason I drew the 00, the extra zeros that weren't really needed, is to get it looking like the answers on the other page where we have it to 4 decimal places. So what we're saying here is the probability, and we don't know what this is. What are you? Question mark. I don't know what that is, but I do know that the probability that X is less than or equal to that mystery question mark equals 0.9500. So this is like Jeopardy. We have the answer from the calculator would tell us 0.9500. We need to know the question. So let's go back to our calculator. We know the mean. We know the standard deviation. We know the direction is less than. We don't know this box. We don't know. It's not 0 because look at our picture. We can tell it's not 0. If I put in 234, that's half of it, 0.5, right there's half. And we could keep guessing to figure out what these numbers are, like 250, nope, not quite, 300, too big. You see, so we could kind of bounce around. But we could cut to the chase by just going over one box and typing 0.9500. Voila, now we have our weight, and it does say to round to the nearest whole number. So for A, we can see 290 pounds. So this value that we just found out right there is 290. So our answer is 290 pounds. Okay, now let's look at B, which is, I wrote a whole bunch here, but I'm hoping to fit, I don't know where I'm going to fit this picture. Okay, I'll just try it down here. This time we want the lower 10%. So that's going to be just this little part. 10%, we know P of whatever this is 10%. I keep looking at the wrong camera. You don't have to put the extra zeros. 10% is 0.1. It's 0.10. It's 0.1000. It's any amount of zeros that you want at the end. So we're on the same problem, we have the same mean, the same standard deviation, that now we have a different percent. I'm going to go over here, change it to 10%. So I could put 0.1, and that gives me 190, or I could put 0.1000, and it gives me the same answer. So this one right here is 190 pounds to the nearest whole number. Okay, last but not least, so that was B. Now for C, it's a little different because it says the middle 50% of the distribution. Now, if it was talking about this, I'm going to just make this without my calculator for a minute, and then I'll add in the calculator. That way I can draw my thing better. Okay. Here is everything, the 235. Oh, it's 234. I hope I typed that correctly into the calculator. Hang on a second. Oh yeah, so if you look at the top right here, it tells you mu, so you don't have to go back every time. It tells you mu is 234, and then the standard deviation is 34. So I typed it correctly. The answers are correct. I just need to quickly fix that. It's supposed to say 4. Oh gosh, what am I erasing? Just that. That is supposed to be a 4. I did it right on the calculator, so that's good. Okay, the middle 50%. Now the middle, this line right here, actually is 50% because remember the mean, the median, and the mode are all equal for normal distribution, but that's not what this question is asking for. What this question is asking for is the two numbers that cut this so that this middle right here, this that is not a pen, this middle part is 50%. So we want that middle area to be 50%. So what is that? We've talked about this before. I'm going to draw number 6 for a minute and then I'll erase it. But we've talked about this before with the 5-number summary. We have our number line, cut it in half again. And this right here, we called it the IQR. That was the middle 50%. It was in between 25% and 75% because each one of these represents a quarter, 1 quarter, 2 quarters, 3 quarters, 4 quarters. Well, these middle parts right here, that's 2 quarters or 50%. So we're looking in between, I'm going to write this, we want the probability in between 2 numbers. We don't know what they are. We'll just call them x1 and x2. But we want, what am I doing? There's so many, oh, I don't want to call it x. That is so confusing. We will call it question mark 1 and question mark 2 because x is the middle part. Something and something else that equals 50%. Clear as mud? Oh, wrong camera. Clear as mud? I know. Let's look at the calculator and see if we can clarify any of this. So put this back. I don't know. Oh, I can shrink it to see what's happening here. So I go to my calculator. Oh, wait, why is this not stretching out? Okay, so I go to the calculator and I have same mean, same standard deviation. I want in between, but I need that in between these two numbers to equal 50% or 0.5. Enter, voila, I have my weights. Nearest whole number. Where in the world will I possibly write this? The answer to C is going to be, hopefully you were writing a little more condensed than I am. 211 and 257 pounds. Because it says it's in between what two weights? So it's in between 211 to the nearest whole number, 257 to the nearest whole number pounds. Okay, so same thing, but backwards. Let's look at the next one. And I'm going to get rid of this. I wonder if I could just select it all at once and just delete it. Okay. Suppose the scores on a biology test are normally distributed with a mean of 74 and a standard deviation of 5. If P is between, the probability of X is between A and B is 25.25, and A and B are symmetric about the mean, find the values of A and B. All right, sounds fancy. It isn't any fancier than anything else we've already done. So the middle is 74. We're trying to find that 25%, the numbers that represent that 25%, and it says it's symmetric about the mean, which just means it's the same distance away on both sides, which is perfect because that's what the calculator is going to give us. So we want to find that where this represents 25, 0.25. So I go to my calculator and I'm trying to find, again, question mark 1 and question mark 2. Or actually, you know what? They gave us better. We can do better than that because they gave us values for this. We're going to call it A and B because that's what they wrote right here. The probability that X is between A and B is 25%. I go back. I need a mean of 74 and a standard deviation of 5. I want between, and I want this to be 25%. And you're going to see in the picture that the calculator always gives us that value that's symmetric about the mean. The mean is right here in the middle, and the two numbers are equal. So if we folded it in half, it would be equal. So we are getting round to the nearest integer. So we find that the probability, we have 72 x 76 is 0.25. This is the answer, 72 and 76, because it says to round to the nearest integer. Okay. Now we have a little different problem. It's talking about milk. A gallon of milk is normally distributed with a mean of 8.6 pounds and a standard deviation of 0.3 pounds. Find the highest weight of a gallon of milk such that the weight less than this mystery weight represent 80% of the population distribution. Okay, nearest 100th place is the answer. Remember, this isn't probability, so we're not bound by that 4-digit rule. Okay, we want to find weights less than lower 80%. That means starting from the bottom, we want to go up 80%. So our mean is 8.6, and we want to color in the left 80%. Remember, percent, probability, that's where the 4 decimals come from. You don't have to type the 4 decimals into your calculator, but just for consistency to make it so that it's familiar from other problems, I'm writing it out in 4 decimals. So we're trying to find the highest possible weight. So that is what we're looking for. That value right there, that's the cutoff between the lower 80% and then the 20% above. So I'm going to write out the probability that X is, now this is drawn to the left, so we want less than, and it also tells us less than. Whatever we're looking for is 80% or 0.800. Going to the calculator, the mean is 8.6. The standard deviation is 0.3. And it's already set up to less than, I don't know, X. Okay. When you mess up and you have something, just put a number in. It doesn't matter because I'm going to go over here in a second anyways and find the answer and retype it. So 0.8000, it just automatically shoots it over to 0.8. That's fine. And nearest hundredth place. So here, this question mark that we just solved for is 8.85 pounds to the nearest hundredth. That's the answer that we're looking for, is 8.85, because we're looking for the data value, the X in this example. That makes sense for this answer because the mean is 8.6, and that's in the middle, and we're looking for something bigger than the mean. The standard deviation is 0.3, so we're not talking about something significantly bigger than the mean. If you told me that your gallon of milk weighed 90 pounds, I'd say, yeah, that's not a gallon of milk, right? So it has to be somewhere near a gallon of milk for our answer. So 8.85 is a reasonable answer. Okay, last one, the weight. Oh, look at us with our milk. Same that, find the middle 70%, the metric about the mean. Okay, as a reminder, metric about the mean is nothing scary. It's just exactly what we want to get for our calculator. So I have the middle. That's what I'm looking for. I know, get out of here. I know the exact middle is 8.6, just like above. I want in between these two values. I'm trying to figure out what those two values are. And this middle part right here is 70%. So there is my 70%. So I'm trying to figure out the probability that question mark 1 is less than or equal to X is less than or equal to question mark 2. All of that equals 0.7000. I like to write it out. I know I said this 85 times, but I don't care. I like to write it out and draw the picture so then I see it matching my calculator and I know I'm good to go. So I go back. No, I don't even need to go back because I already have this mean and standard deviation. And again, you can double check right up here at the top. It says the mean is 8.6. The standard deviation is 0.3. And here is our picture. Now I don't want less than. Ooh, I don't want to just jump to some random page either. Okay, I don't want less than. I want in between. So I go over to in between. I don't care. I don't care. That's what I'm trying to find. I'm going to go over to the last value. Type in 0.7000. And I see my two mystery values are, that one is going to be 8.29. It says hundredth place, 8.29. And then that one is going to be 8.91. So those are the two values. Notice that 8.6 is right in the middle, which is what it should be. The mean should be right in the middle of those two. And we have our two values. And looking at the picture, that middle shaded yellow part, yellow-orange part, is the middle, so we talked about 70%. Okay, let me get out of here real quick. Oh gosh, I clicked something on my other computer and it messed it all up. Stop. Okay. This is new. This is different. Make sure you're getting the hang of it because chapter 6 is really just about practicing. Yes, there's a little bit of paragraphs in here, but we're just practicing the skill that we're going to really mess with in chapter 7. So you need to have a good foundation of it in chapter 6 in order to add on to it in chapter 7. So rewatch or redo any of the videos or assignments you need to make sure you really understand especially 6.3, because 6.3, the one we just did, ties everything together. So anything that you need to redo on 6.3, make sure you understand it before going on to chapter 7. All right, email me if you have any questions, and I'll